Na početku samo da kažem da će predavanje biti na engleskom i ja ću isto tako iskoristiti priliku da uvod za naše gosta i sve u ostatku večeri pokušam da govorim na engleskom. Good evening, everybody. We are glad that you are here tonight, and we are glad that our speaker, Dr. Tim Standish, is here with us tonight as well. Before we give him opportunity to speak, I'd like to say a few words about him. He has a PhD in biology and public policy. He completed his Bachelor of Science at Andrews University in zoology. He got his master's in biology also at Andrews University, and he got his PhD in biology and public policy at George Mason University at Washington. He told me he's married, has one wife, one daughter, and has 2 dogs. He is senior scientist at the Geoscience Research Institute at Loma Linda University that is run by Seventh-day Adventist Church, and that's preoccupied with the topics similar to the ones that we'll hear about tonight. Without any further ado, I'd like to welcome him to our church and to Toronto, and pulpit is yours.
Well, thank you very much. It's my pleasure to be here with you this evening, and I hope that what I say will not be misunderstood. I have to be very careful about what I'm about to do, because I have to confess that even though I consider myself to be a brilliant teacher, or at least I try to be a brilliant teacher, sometimes people who listen to this particular presentation actually get a different message than the one that I'm trying to convey. The point that I want you to appreciate this evening is that irrespective of the amount of time that it took to form the fossils that we find in the fossil record, independent of that issue, the time issue, there is abundant evidence of design in the fossils that we find in the fossil record. So this evening, you will hear me talking about millions of years and hundreds of millions of years and billions of years. That is not because I embrace those numbers. It is because those are the conventional numbers that people talk about when they talk about the fossil record. I will use those numbers, okay? But please do not go away with the impression that I am saying that the earth and certainly life on it is actually hundreds of millions of years old or something. I actually believe the Bible, and I believe that life is relatively recent when it comes to the earth. So I want to be absolutely plain about that, and I am tempted to have you all repeat after me, but we won't do that exercise. But please do understand that I am a Bible believer. However, for much of this evening, I will be using conventional numbers that are commonly agreed upon in the scientific community, even though I do not agree with them. So let's have a look at that conventional history of everything from the perspective of what I would call normal, the most widely accepted view within the scientific community. So we start off here, let's say about 13 billion years ago, with the Big Bang. Now, it might be plus or minus a billion years or so, but we start off there. And all sorts of things happen over the course of the next, let's see here, what is that, 9.5 billion years or so, or 8.5 billion years. And we finally get to 4.5 billion years ago. At this particular time, it is thought the earth formed from dust that was out there in the universe. And it all comes together, and it is extremely hot. It is a molten ball out there in space, presumably going around the sun at this particular point. But obviously, a molten, white-hot ball of lava is not a likely place for life to develop, particularly carbon-based life. So we have to wait some period of time after the Earth initially forms before we can start having life form. Now, most of this time after the Earth forms into a ball, there is very little in the fossil record. There are rocks out there that we call Precambrian rocks. In these rocks there are some fossils, but they are rather rare. By the way, you here in Canada have a fair number of Precambrian rocks. It isn't until you get into these very last few layers of rock that you start seeing abundant fossils. They first show up in a layer of rock called the Cambrian. They're called the Cambrian rocks because they were first characterized in Wales, and Cambria was basically the Latin name for Wales. So that's how it got its name, and there are abundant fossils in these Cambrian rocks and in all the rocks that you find piled up on top of the Cambrian rocks. But below that, there's very little. So let's have a look at what's going on here. 4 billion years ago, the crust of the Earth forms. Obviously, before that crust forms, you're probably not going to have life evolving or anything like that. By 3.5 billion years ago, there is definitely life on Earth. There's pretty good evidence in the forms of fossils and certain carbon that is in a certain form that tells us that there was life. In fact, there are a number of papers that claim that life first appears on Earth about 3.8 billion years ago. So that's actually not very much time for the life to first appear on Earth, 200 million years. I always imagined, back when I was, before I really got into studying these things, that there were billions of years for life to come into existence on the Earth. That's not the case. While 200 million years does seem like a long time to me, it's not very much. In terms of geology, you could say it's very, very, very fast that life appears. And then we have all of these other events that are going on there. But you get the basic idea. This window of opportunity for the formation of life is narrow. And that surprised me when I first found out about it. There is a rule that is typically used in science when it comes to interpreting the evidence that we see there. And it has to do with something called teleology. Teleology is the idea of having a goal that is being worked towards. Within the materialistic, atheistic Darwinism that is commonly practiced, teleology is not allowed. Nature does not have goals because nature is not intelligent in and of itself, and it is not guided by any kind of intelligence. There is no plan that is working towards a goal in nature, according to the common understanding of things, and so on. Fossil organisms, however, are like living organisms. They exhibit systems that are necessary for their survival and require multiple integrated parts. So consider when an engineer is designing a car. for example. That's a relatively simple machine. And when that car is being designed, the engineer breaks things down and thinks about, how am I going to achieve the goal of having a car? Well, let's see here. I need to have an engine. I need to have wheels. I need to have a way of transmitting the power from the engine to the wheels. All kinds of problems, engineering problems like that, that need to be worked out. That's teleology. When you look at organisms, it looks as if there was some sort of teleology that was necessary to bring together all of these integrated systems that then achieve the goal of being a living organism. It looks like somebody anticipated a problem and thought of a solution to that problem. And by the way, this is not an overly controversial view. Even people like Richard Dawkins, who is an enthusiastic atheist, I would call him an atheist evangelist, he writes about how nature has the appearance of having been designed for a purpose. However, he then says it's just an illusion. It is not real. And he is not the only Darwinist who talks about this. Famous Darwinists like George Gaylord Simpson, for example, also talk about things in these terms. In our experience, however, only intelligence is capable of having a goal and figuring out a series of steps to achieve that goal and then carrying them out. That's what intelligent beings do. That's what we see engineers doing. We don't see iron ore and hydrocarbons and so on spontaneously arranging themselves into vehicles. That would be convenient if they did that, but that's just not the way nature works. Nature does not have occult properties in and of itself that cause it to arrange into things like remote controls or the clothing I'm wearing or the seats you're sitting on or the cars that you drive or the computers that you use. That requires intelligence. And it looks as if living things require stuff like that as well. I want you to consider just one problem that you can see had to be solved in a fossil organism. This particular organism is a kind of dinosaur. And this particular dinosaur is found in the Natural History Museum in Berlin. Now, you know how the Germans are. I can say this because I come from a German family, even though I have a beautiful English name. And yes, I kind of feel this way myself. If I'm going to have something, I want it to be special. And this particular dinosaur is special. It's special because it is the tallest mounted dinosaur that has ever been done. And just to prove it, I guess because they're Germans, they have the Guinness Book of World Records certificate set up there right in front of their tallest dinosaur. And the Guinness Book of World Records people came and measured it, and it's not just 13 meters tall or 13.2 meters tall, it is 13.27 meters tall. Now, I know that you are Canadians, and you know what a meter is, and you know that 13.27 meters is really, really, really tall. I personally had the experience a while ago of falling 8 or 9 meters. And I can tell you it really, really hurts to fall 8 or 9 meters. I didn't go up and measure exactly how high it was that I fell from afterwards because I feared falling 8 or 9 meters again. So I don't know. If I had been this dinosaur, I would have been nervous holding my head up that high. It's a long way down from 13.27 meters. And yet, that seems to be what this dinosaur did. Now, you can excuse me for being just a little bit skeptical. I wonder whether, in fact, they haven't sort of mounted this dinosaur a little bit unnaturally to get it to be the highest one in the world. But whether they did or not really doesn't matter, because however high this thing was, it was really, really a tall dinosaur. 13.27 is amazing. I want you to compare it just a little bit to the closest thing that we have in the modern world, and that would be a giraffe. Now, a tall bull giraffe is about 6 meters tall. You might occasionally get an example that's a little bit taller than that. But 6 meters is a really tall giraffe. And 6 meters comes up to about the shoulders of this dinosaur in Berlin. So 6 meters is less than half as tall as this thing. There's no way that the shoulders of this dinosaur were shorter than 6 meters. So let's think a little bit about one problem that has to be solved if you're a dinosaur, if you're a giraffe and you want to be 6 meters tall. And that one problem has to do with hydrostatic pressure. The taller something is, the higher the pressure has to be to get blood to go from the heart to wherever the top is. And as a consequence of that, these giraffes have to have very high blood pressure. Their blood pressure is 280 over 180. If you have blood pressure that is that high, you will not have it for very long, because you will die very shortly. Okay? It might be possible for a human being to survive for a very brief period of time with blood pressure this high, but not for very long. Why is it that we can't survive with high blood pressure like that? Well, one of the reasons would be because our blood vessels are simply not strong enough to stand it. If we want to have blood pressure that high, we then need to strengthen our blood vessels. Right? We also need to have a heart that is designed to pump that high pressure. And there are a number of other things. But let's continue on. Yes, it turns out that giraffes have to have very strong blood vessels. They also have to have a powerful heart. Now, strangely enough, people used to think that that meant they had to have a very big heart. But they don't have very big hearts. They have a normal-sized heart for a creature of their size. Now, it is a big heart, but it's not unusually big for a creature of their size. The heart has very thick muscles. It's a very thick muscle, which means that it has very small, relatively small ventricles. Okay, that's the part inside the heart that's actually the empty space that the blood flows into and then is pumped out of. So, that creates another problem. The volume of the ventricles is relatively small, so how are they going to move enough blood? Well, they have to change the way their heart beats. It can't beat slowly, at 60 or 70 beats or whatever it is that a human heart beats at. It has to beat very, 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 very rapidly to move enough blood. So it has to have a rapid heartbeat. Can you see that there are multiple variables that all have to come together so that a giraffe can be as tall as it is, just in terms of blood, moving the blood around there. And, this is the coolest thing. I don't know why I enjoy this so much about giraffes. But remember that the blood has to go down into their feet as well. but then it has to come back up to their heart. How do they get it to come back up? Well, they do the equivalent of wearing tight stockings. Sometimes, by the way, people with heart failure, they will get blood and fluids accumulating down in their legs. So one of the ways of dealing with that is to put elastic stockings on to move that fluid back up. But giraffes have it built in. The skin on their legs is really tight, and that forces the blood to come back up from down there at their feet. Can you see that this is a very integrated system that is going on here that allows a giraffe to be about 6 meters tall? Everything that a giraffe had, and more, had to be going on inside these 13.27 meter tall dinosaurs. Even if they were a bit shorter, let's say they were only 10 meters tall, they still had to have amazing systems that allowed them to be that tall, just to deal with the problem of moving blood under very high pressure around their bodies. The fossils themselves give us very important evidence about design. Possibly the best evidence of design in the fossil record is the fact that fossils represent once living things. This means that because they're living things, because living things today give abundant evidence of design, like the giraffe, solving all of these problems that require multiple integrated convergence of variables. Because of that, there's reason to think that organisms for the past were also designed. Just because something is extinct doesn't mean it was more primitive. It means it's extinct. Okay? There could be any number of reasons why it went extinct. And it doesn't mean that there were not sophisticated systems in there that suggest that they were designed. I want you to think a little bit about the kinds of organisms that we do see in the fossil record, because they really do look like what we see living today. This example here is a chambered nautilus, and you can see the fossil on the left and a modern example on the right. In terms of their shells, they don't really look different. In terms of the soft parts, it's pretty hard to tell because you don't find many fossils of the soft parts. There are some out there. But they give every indication of looking like modern creatures. They don't look like they changed very much. Here's a grasshopper. Several of these that I'm going to show you are from Solnhofen in Germany. Solnhofen is just amazing for the fossils that it preserves. Now, these are all Jurassic fossils. So these are things that lived at the same time as dinosaurs, and there might be slight minor differences between them and the ones that we see today, but they're very minor. Grasshoppers are still grasshoppers in Jurassic rocks, and dragonflies are still dragonflies in Jurassic rocks. And this is fantastic. Yeah. Do you have geckos here in Canada? Yeah. Have you ever? No, I'd be surprised if you did. But do you have any lizards that if you pick them up, they get all excited and lose their tail? Yes. Yeah. Mm-hmm. And what happens after they lose that tail? They grow the tail back, right? I kind of wish that I had that capacity with this finger here. But we don't. That's what happens when you fall 7 or 8 meters, among many other things. Don't do it. In any case, when it comes to this particular creature here, it's a kind of lizard like a gecko. It has lost its tail, and its tail is growing back. It doesn't look less sophisticated in any way than modern creatures do. they look about the same. Sharks are amazing. And shark fossils are kind of unusual. But when you look at shark fossils, they're instantly recognizable as sharks. And in fact, you can identify them within certain shark groups that we have living today. Not all of them. There are some extinct groups as well. But they don't look profoundly different. And you can see certain interesting things about sharks. Like, can you see the asymmetrical tail on the shark here? That's something that we see in modern sharks. In fish, typically the tail is symmetrical. It's kind of like an equilateral triangle shape type thing. Whereas sharks, the top part of the fin tends to be bigger than the bottom part of the fin. And this has to do with how they swim, and it's one of the things that just makes them look cool. But anyway, in fossil sharks, you see the same types of things. Now, you might say, well, what about the creatures before these creatures? Before those appeared in the fossil record, there should have been a whole lot of missing links that led slowly to them, and somehow or other through slow, small steps, which is the claim that Charles Darwin makes, through slow, small steps, we could muddle our way, and there should be these missing links that show that, towards these amazing integrated systems. I want you to think about that just a little bit. With the giraffe. I know you've probably seen cartoons of giraffes, stretching out their necks and getting taller and taller or something like that. However, there isn't a fossil record that really shows that. When giraffes show up, like just about everything else, they have long necks and they're quite tall creatures. So, is there a reasonable incremental path that you could go by? I mean, which came first, the high blood pressure or the strong blood vessels? Well, if you have the high blood pressure and you don't have the strong blood vessels, how long are you going to last? Not very long. Okay. One of those blood vessels is going to blow, and you will be dead in a very short period of time. So you need the strong blood vessels first. But why would you evolve strong blood vessels if you don't have high blood pressure? It doesn't, and yet you've got to have all these variables come together. And obviously many, many, many other things to get a creature like that. Charles Darwin actually recognized this. And he asked the question. He says, why then is every geological formation and every stratum, why then is not every geological formation and every stratum full of such intermediate links? Okay. And then he goes on to say, geology assuredly does not reveal any such finely graduated organic chain. It's not there. Those links, and by the way, I want you to notice something about this. Charles Darwin does not say there should be one or two missing links. One or two links between these different kinds of organisms. His theory predicts abundant missing links. Missing links should be the norm. They should not be the exception. Now, I don't know, whether Canadian newspapers are like American newspapers or English newspapers or Australian newspapers, because frankly, I haven't spent much time reading Canadian newspapers. However, in other parts of the world where I have read the newspaper, what you see is every now and again really big news in the science section when a missing link is thought to have been found. A few years ago, there was a great missing link. I'm telling you, it is the best potential missing link I've ever seen, I think, in my lifetime. It was supposed to be between a fish and a land creature. It represents one of the missing links that you should have between fish that swim in the ocean and creatures that crawl out and walk out on the land. Our ancestors, if you will, in the evolutionary Darwinian kind of scenario. It was called Tiktaalik. And it was really, really, really a good candidate. It was huge news, at least in the sciences. Why? One or two of these things is not what Darwinism predicts. It predicts a geological record, a fossil record full of these things. Why aren't they there? By the way, it turns out that Tiktaalik cannot be a missing link because what you find in layers of rock below Tiktaalik, and therefore older than Tiktaalik, are trackways of tetrapods. These are the four-legged creatures that walk around on land like you and me. So it can't have been a missing link that was evolving into these things. They were already there before it shows up in the fossil record. Look at what Charles Darwin said. He said, "Geology assuredly does not reveal any such finely graduated organic chain, and this, perhaps, is the most obvious and serious objection which can be urged against the theory." This is his theory of evolution. "The explanation lies, as I believe, in the extreme imperfection of the geological record." Now imagine if I came to you this evening and I said, "You know what? I believe the Bible, but the evidence doesn't support the Bible. And I believe that's because the evidence is no good." For all practical purposes, this is what Charles Darwin is saying here. The reason the geological record does not support my theory is because the geological record isn't very good. So next time somebody says to you, "Well, come on, geology shows that Darwin had it right," Darwin himself did not believe that. He said that but is he correct? Is he correct that the geologic record, in fact, does not support, does not have a good record of what occurred in the past? Well, people have been looking for over 150 years now at the geological record with incredible scrutiny, looking for missing links, looking for patterns in there. And in fact, what has been found is, exactly what Charles Darwin noted. The missing links continue to be missing. Now, I can assure you that if somebody watches what I'm saying this evening on YouTube, they will get on there and respond and be yammering on and saying, "Oh, no, there are abundant missing links out there," and so on. The only way you can say these sorts of things and not be completely ignorant or lying is by redefining terms. And so occasionally people redefine terms in a kind of, Orwellian kind of way, and they get it out of that. But what you think of as a missing link is not what they mean when they say that they're there. And they are not what Charles Darwin meant when he wrote about that either. So anyway, basically 150 years since Charles Darwin published The Origin of Species in 1859. Here, a little bit before the 150th anniversary, we have this paper that appeared in Nature. It was printed in 2000. Nature is one of the arguably the most prestigious scientific journal out there. And the authors talking about this question of the quality of the fossil record. How good is it really? They say this: ancient rocks clearly preserve less information, on average, than more recent rocks. However, if scaled to the stratigraphic level of the stage, so this is, as these layers of rock are categorized into different groups and so on, a stage is, a significant group of rocks, but it's not a massive one. And the taxonomic level of the family. So this is talking about how organisms are categorized. We're categorized in kingdoms, so we're in the kingdom Animalia, we're animals. By the way, I know that for some people that's controversial. No, the Bible is quite plain. We were made in exactly the same way as the animals. They just as we were formed by God out of the dust, the Bible is very clear. God also formed the animals out of the dust. Just as we have the breath of life in us, the animals have the breath of life in them. Sometimes people try to imagine that we're different in that respect, and we're not. The difference is human beings were made in the image of God. Okay? But that doesn't mean that we are not animals, any more than the Venus de Milo is made out of rock, but it's in the image of a human being. Same basic idea, at least as far as I can tell. So, what they say here is, so we are in the kingdom Animalia. We're categorized into the phylum Chordata, and then you go kingdom, phylum, class, order, family, genus, and species. So family is a pretty fine group within the taxonomy of organisms. And so the stratigraphic level of the stage, taxonomic level of the family, the past 540 million years, that happens to be from the time of the Cambrian explosion, when all of a sudden you have all of these fossils appear in the fossil record. Remember, the Precambrian rocks don't have many fossils, and by the way, they don't look much like ancestors of what shows up in the Cambrian. So that's 540 million years of the fossil record provide uniformly good documentation of the life of the past. So claiming that the fossil record simply is not good enough to reveal those missing links doesn't seem to be the way things, a particularly good explanation anymore, as far as we can tell. Those fossils are simply not there. As far as the, basically 300 million or more years, 3 billion or more years of the Precambrian rocks, where you do find something, you should find a zillion missing links in those, because they cover an awful lot more time. And yet what Stephen Jay Gould, again an eminent proponent of the Darwinian theory, he wrote, "The Precambrian record is now sufficiently good that the old rationale about undiscovered sequences of smoothly transitional forms will no longer wash." Okay. So you do not see these complex integrated systems that we know were present in these organisms. We do not see, there's no evidence of them gradually evolving in any way. They're the kind of thing that looks like they require an intelligence to sort of bring all the systems together. The Darwinian claim is that's just an illusion, and they actually evolved in a slow, step-by-step manner. But we do not find evidence of that in the fossil record. the evidence that we find is they suddenly appear fully formed. So I'm going to just zip over this particular slide. I was going to give you some more sort of details about what's going on in this fossil record. There are interesting patterns there, multiple patterns that are inconsistent actually with the Darwinian theory. But we will just go to this. Oh, I guess you should note there, can you see this layer? Let's see, I know that I've got a point here. This one right here, the Cambrian. This is the layer where it's believed most phyla, at least, of organisms that we're familiar with show up. And boom, they show up, and below them we do not find their ancestors. So it's a very dramatic kind of event, if you want, in the fossil record. There are fantastic, probably what used to be considered certainly to be the best Cambrian fossils came from Canada, from something called the Burgess Shale near Banff. I've hiked up to the Walcott Quarry there and seen where they got these things from. I mean, they are incredibly great fossils. But more recently in China, they have found even older, still in the Cambrian layer of rock, but supposedly older fossils in the Changjiang Formation. And these fossils are anatomically complex. Now I'm going to start off with something that's considered to be a relatively anatomically uncomplex organism. This specimen here is a kind of sponge. It's a kind of sponge that we find living today. That's why we can recognize it. And sponges, while they're not complicated in the same way that you're complicated, they can do things that you can't do. For example, you can take a sponge and you can put it through a sieve and break it up into, obviously little bits, and it can rearrange itself back into a sponge. I wish people could do that. It would be kind of cool, but we can't. This is a kind of sponge. They have amazing abilities, and they are incredible creatures. This here is a kind of nematode-like organism. I happened to do my PhD working on nematodes. That was the model organism that I used in my research, an organism called Caenorhabditis elegans. Now, I can tell you that while we consider nematodes to be relatively simple organisms, after all, they're just worms, they are phenomenally complex, amazing, beautiful, incredible, wonderful creatures, even though nobody cares about them. Well, yeah. No, they are really, really amazing. This one I particularly like, Heliomedusa. Also, I like it because it illustrates something about the way scientists, we're just not right all the time. It's called Heliomedusa because it was thought to be the fossil of a kind of jellyfish. But that's not the case. This is actually a fossil of a kind of brachiopod. Brachiopods look a little bit like clams, but they are profoundly, profoundly different things. And anybody who did their master's degree working on brachiopods, like, well, me, will get all excited telling you that clams have bilateral symmetry that goes this way, so their shells are typically mirror images of each other. Okay? Typically. You get exceptions, but typically that's what they are. Whereas a brachiopod does have two shells, but the plane of symmetry goes down through them like this. Okay? So they're bilaterally symmetrical in a very different way. And they have a whole different kind of feeding structure, and they're amazing, but we won't spend the rest of the evening on them. Fabulous, fabulous creatures. This is another kind of brachiopod, Linguella. Again, this one truly astonishes me because you find them in the Cambrian and you find them living today, and they look about the same. And you find them pretty much throughout the fossil record in various places. they haven't evolved very much. I mean, in the time that things have gone from things that look like fish without jaws, according to the evolutionary theory, into giraffes and elephants and human beings and all of that sort of thing. In that period of time, these brachiopods have gone from this kind of brachiopod to this kind of brachiopod. They're still the same, which is kind of interesting. Here's an example of a modern one. Here's another interesting thing about the fossil record. Lazarus species. The fossil that you see there is from Australia, and it is a very distinctive kind of plant fossil that we now call a woolly pine. These were thought to have gone extinct about 2 million years ago. And yet recently they were found growing quite close to Sydney. In fact, now you can get them and you can grow them anywhere. This particular example that I've got a picture of here is growing on the campus of Avondale College, which is also not very far from Sydney. Now, this is probably not the greatest example of a Lazarus species, but I happen to have a fossil of one. Today, we went to the Royal Ontario Museum, is it? Yes. And they had something, a model there of something called a coelacanth. It's a fish about this big. Sometimes they get a little bit larger, about that big. And this fish goes extinct in the fossil record something more than 50 million years ago. And we find it living today, both off, now it's a population's been found along the east coast of Africa and also off the north coast of Sulawesi in Indonesia, somewhat surprisingly. Who knows where else these things may be, but if they disappear for 50 million years or more from the fossil record, why should I believe that they didn't live for 50 years before they appear in the first place in the fossil record? It's kind of an interesting thing. There are multiple other examples of these things. In fact, they're relatively common. Probably monoplacophorans are the most dramatic example of these things. They disappear over 300 million years ago. And yet we find them living in the ocean today. They produce a shell. They do everything that should make it likely that they get fossilized, except they just don't, supposedly for 300 and something million years. A very curious thing. But anyway, getting back to this. In addition to being anatomically complex, fossils indicate significant biochemical complexity existed when they were living, as this was necessary for life. So we've been looking at anatomical kinds of things. But what about at the biochemical level? That's where things get truly beautiful and complicated. Let's just consider proteins. Proteins are made out of amino acids, and they're joined together in very specific orders, and then they're folded in very specific ways, and they make these little molecular machines that are absolutely necessary for you to be alive. The example that I'm showing you here is something called glyceraldehyde 3-phosphate dehydrogenase. It happens to be in the middle of a biochemical pathway, the biochemical pathway that is turning your supper into energy right now. It takes sugar and breaks it down and converts it into energy. The interesting thing about this pathway is that before you get to glyceraldehyde 3-phosphate dehydrogenase, you have to put energy in. After glyceraldehyde 3-phosphate dehydrogenase, you start to get that energy back out. And you wind up with more energy than you put in the first place, obviously. Imagine how a system like this evolves. Each one of the molecular machines is at least as complicated as the very simplified model that I'm showing you of this particular enzyme. But you've got to have basically all 10 steps in this pathway, or it doesn't do any good at all. It just consumes energy, and you need the energy from that sugar. How do you make something like one of these molecular machines in the first place? Normally, if with anything else, we would answer that question by comparing it to something that we know. How do you take bricks and turn those bricks into something like, I don't know, this church that we happen to be in right now? You can take bricks and you can build any number of things out of it. You can make a hospital, you can make a church, you can make a school, you can make a house. You can make different styles of houses out of the same kinds of bricks. The same sort of thing is going on with living things. You can build out of the same bits and pieces lots of different things. How do you get the things that we actually have? How does that happen? Well, that's a big question. And it's a particularly big question for anybody who understands photosynthesis. Have any of you ever studied photosynthesis in school? Yeah. Were you impressed by it? Yeah. Did you think at the end of studying photosynthesis that you actually understood it? Yeah. I know you're interested in coming to Loma Linda University, so you don't have to admit anything, but you know what? Yeah. When I studied photosynthesis, I studied it probably for the first time in high school. And I thought to myself, well, that's kind of interesting, but I think I've got the basic idea here. And then I went on to college and I studied it again. And you know what? It was a lot more elegant than I'd thought it was. But after my freshman year of biology, I kind of thought, yeah, I probably have that down, but it was a bit more than I thought. And then later on I did biochemistry. We looked at photosynthesis again, and wow, it was so much more than had ever occurred to me. And then I went on to graduate school, and I took this fabulous course called Microbial Physiology and Metabolism. And we looked at photosynthesis again, and I thought to myself, this time I'm really going to understand it. And I sat down and I worked on photosynthesis like you wouldn't believe. Yeah. I actually balanced the Calvin cycle, and that's not trivial. And yes, and a lot of other things. And you know what? By the end of it, I realized that I'm not going to understand this. This is really amazing. Yeah. We don't truly understand what's going on, but it is truly, 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 truly a complicated, beautiful, elegant thing that requires all kinds of amazing molecular machines to work. The very first thing we find in the fossil record is evidence of photosynthesis. It's not that we find evidence of the simplest biochemical pathways at the beginning of things. We find evidence of what is arguably the most amazing, most elegant, most vital for the existence of life biochemical pathway. That's what we find first. And these things, in our experience, with anything else, our experience is these types of things require geniuses to design them. Why would we imagine that they didn't require genius to design them in living things, even the fossil remains of living things? Give us naturally draw us to that conclusion. Fossil organisms also suggest behavioral complexity that anticipates certain needs, including those of offspring. So here we have the largest known marsupial, Diprotodon, Australis. I don't know why they came up with that name, what with it being found in Australia, and so on. I've been told, by the way, that there are lots of very sort of biggest and best things in the world here in Toronto. Well, Yonge Street is the longest street in the world, or something like that. Yeah, this is what I've been told. Well, we have the biggest marsupial in Australia. Yeah. And What's special about marsupials? What do marsupials do with their young? They have a pouch, right? They have a very intimate way of taking care of their young. And so when we find fossil marsupials, they presumably had the same methods of taking care of their young. A year or two ago, I took this photograph. And I should probably confess to you what happened. It was a Sabbath morning. I was hoping to sleep in a little bit. And one of my dogs went berserk, barking out the front window of the house. And I thought to myself, I'm going to ignore it. It's going to stop. I'm going to stay here in bed and sleep just a little bit more. But my wife got up and looked out the window. And then she started calling me. So I got up and went and looked. And lo and behold, this is what I saw across the street in the neighbor's yard. Here is the neighbor's cat confronting a possum. And look at this mother possum. Can you see all her babies on her back? They've outgrown her pouch. But she's still taking care of her babies, and she wasn't going to let that cat anywhere near her little babies. That just wasn't going to happen. Organisms in the past cared for their young as well. That involves anticipating a need. Imagine with human beings if ladies just gave birth to their young and walked away. How long would the babies last? Not very long. Okay? But God has prepared women to take care of those young. They're designed to do that. I found out the most astonishing thing recently, that women actually produce different milk for baby boys versus baby girls. They each get their own custom, custom combination, I guess. There. It's quite remarkable. Organisms, not all organisms take care of their young like this, but organisms that have young that need to be taken care of are equipped to do it. And that requires anticipating a need before the need arises, because otherwise you're in deep trouble. Let's end up by talking about trilobites, because they're one of my favorite fossils. You find trilobites, I have an example of one right here, all the way down in those Cambrian rocks. In fact, I'll pass this one around. If anyone's interested in it, just please do give it back to me. But you can take a look at it. Yeah, because trilobites have parts that are similar to parts found in modern organisms, it seems reasonable to believe that trilobites were about as complicated as modern organisms are. So we're just going to look at one thing, the trilobite's eye. Can you see in the specimen that I have up on the screen what the eye looks like? Does it remind you of the eye of a living organism? Yeah? What kind of eye is that? What kind of eye? Like a fly's eye, right. It's a compound eye. And flies have compound eyes. So you guessed exactly what I was hoping you were going to guess. Here is a fruit fly, and you can see it has a compound eye as well. However, the compound eye of the trilobite is a little bit different. One of the really cool things about these eyes is that they have lenses in them that are made out of calcite. They have stone lenses in their eyes. And there are lots of really cool things about those lenses. Calcite is an interesting thing to make a lens out of. Trilobite compound eyes are similar but not identical to insect compound eyes. And at the molecular level, the same basic systems found in all eyes are thought to have been present in trilobite eyes. flies use the same molecular mechanisms for detecting light that we use. So because both of these are more or less arthropods, we would expect that they would use the same molecular mechanisms. And trust me, these mechanisms are fabulous and interesting, but we won't go into them. They are complex mechanisms. No evidence of their gradual evolution is evident in the fossil record. When you first find trilobites, they have fully formed eyes. You don't see their gradual evolution. Now, not all trilobites have the kind of lenses that I'm going to show you here. But some trilobites have really, really, really interesting lenses. And to understand why these lenses are so interesting, we need to go back a little bit in history. We need to go back to the 17th century. Now, during the 17th century, human beings were discovering things using telescopes and microscopes. Now, when they were using these telescopes, particularly, but also microscopes, they started running into some problems. And the problem arises from the fact that when you bend light, you get a rainbow. With a normal lens, with a normal simple lens, that rainbow can be seen. If you have a cheap camera with a cheap lens in it, and you take a picture of something like, right up at the back of this church, there's a nice example of it. A white wall with something dark colored beside it, you will see a little fringe of light. It's commonly blue or purple. That's because the light is being bent and you're making a little rainbow that shows up in your images. It's called chromatic aberration. That can really limit how well you can see things, and the more you bend light, the bigger the rainbow is. So controlling for chromatic aberration was a big deal. So there was a guy named Descartes. This is the philosopher who said, I think, therefore I am. He's also a mathematician. And he's thinking about lenses. And he figured out that if you made a lens that's this shape that I'm showing you here, it will help to control that chromatic aberration. Causes a few other problems, though. But it was a really good idea. If you look at the lens that's found in a kind of trilobite called Crozinaptus, what you can see is this. The lens is actually made up of two parts. It's called a duplex lens. There is the lens, okay, the front part. And that calcite lens has the same form as a Descartes lens. Think about evolving something like that. How does that come about? Remember that each step in the evolutionary process must be adaptive. So if you had a lens that was a regularly shaped lens, and you start randomly changing in small steps that lens, what's going to happen to the trilobite? It's going to be blind. It's going to have a lens that doesn't focus very well. Is that adaptive? Did lady trilobites find blind man trilobites more attractive or something? It's hard to imagine that they did. Okay. And then you slowly zero in on this new shape of lens. That just doesn't seem like a very good theory, because you're going to be blind for a long time, and being blind doesn't seem to be very adaptive. Okay? There's one other thing that you need to take into consideration here. Basically, this lens is composed of calcite that is made out of what amounts to calcite with different optical densities. And this interlenser body that you can see there is what it does is it helps to correct for some of the aberration that is introduced by this Dakar lens. The two lenses must be perfectly matched together to work. How do you get this in a slow, steady, step-by-step process in which every step along the way results in you having more babies, which is basically what the Darwinian theory demands. Okay? That seems improbable. And this is not the only example. Hyuns, whom the Hyun space probe was named after, was also wrestling with this same problem. He came up with this particular design for a lens to, again, address this chromatic aberration problem, and we find that kind of lens in another kind of trilobite. Now remember, I'm not saying that every trilobite out there has these complex duplex lenses, but it doesn't matter. The fact is, there are multiple trilobites out there with really interesting lenses that they used in their eyes, and those really interesting lenses do not look like the kind of thing that come about in a step-by-step Darwinian kind of fashion. It's not a credible explanation. This is an image of the very first human-designed duplex lens. Now, this was designed for a camera. In fact, many of the old photographs that you see, the kind that were made with a really big camera, and the guy stood under a black sheet behind the camera and everything, that kind of camera, many of them used this particular lens. Yeah. And this lens, by the way, is not perfect. The point is that when you have multiple lenses in there, they have to be matched. They have to be right. Because if they're not, you are not going to have a better image, you're going to have a worse image. No. How do you go from a regular, simple lens to a duplex lens with a very complex shape to it? The kind of shape that we couldn't figure out, by the way, until we'd figured out how to do calculus. This is the same as asking, how do you go from a simple magnifying glass kind of thing to a lens with multiple elements in it, like a camera lens? This happens to be a drawing that I did of a 50 millimeter Canon lens. We know where lenses like that come from. Geniuses in Japan, and there are also some geniuses in Russia who are fabulous with optics. And then but it's always a genius. These things don't, atoms do not arrange themselves into this sort of thing. They get arranged by geniuses. It's brilliance. It's intelligence that does this in our normal experience. Why would we attribute what we find in these fossils to anything else other than design by some kind of genius? Yeah. Does time really help? Not really. If I had a pile of bricks and I put them on a plot of land and I left them there for a week, would they arrange themselves into a church like this? I've never seen that happen. What if I left them there for 1,000,000 years? Would they be more likely to arrange themselves into a church? No. That's not the way things work. What if I left them for 1,000,000,000 years? No. They're still a pile of bricks. Until somebody comes along with a design in their head, a goal. I'm going to build a church. I'm going to build my house out of these things. I'm going to build something, and they have a goal and a plan, and they work towards it and achieve it. That's how you get that sort of thing. Time doesn't really seem to be very useful. Does natural selection help? No. Natural selection actually makes things worse in this particular case, because as you slowly start to go, to evolve towards this superior design, you go blind and then you go extinct. So natural selection really doesn't help. What about, is it possible via natural selection and incremental steps, each of which is a random variation? No, combining them together doesn't help. It just doesn't help. Now, the answers that a person gives to these questions, though, is going to be highly dependent on our worldview. The reason that I am free to see design where it obviously exists is because I'm a Christian. I don't have to see design in everything. I'm not forced to do that. But I'm free to consider it if it looks like it's there. Christianity liberates us to do that. Materialistic Darwinism locks us into basically an incoherent position. Okay? It forces us to say, no, that, it may look like it's designed, but it isn't. That's not science. That's just being blinded by what I consider to be a very restrictive and unhelpful philosophy. It's got nothing to do with evidence and so on. It means that you're shoehorning evidence into a theory into which it doesn't very naturally fit. And that's the end. Thank you so much for listening. I understand that we have some questions or... Thank you. Here, I'll grab that off.
So if you have any questions, feel free to write them, and our usher is here. She's going to bring them to us. And while we wait for these, I'll feel free to start off with a question that developed in my mind as I was listening to you. Okay. It looked to me that you touched the subject of irreducible complexity.
Yes, not in really a formal way.
Yes. When we talk about irreducible complexity, maybe it'd be good to explain, what it is. And also, we know that both sides, discuss this argument. And I think when you talked about giraffe, you just touched it slightly. And how does, a scientist who's an evolutionist, how do they explain it? Because I listened to some of them on YouTube, and they don't seem to be really concerned with it.
Well, yes. First of all, let me explain what irreducible complexity is. This is a concept that was really made popular by an individual named Michael Behe. And what he observed was that there are certain kinds of systems that have a set of parts to them that if you remove one of those parts, whatever the property of that system had no longer exists anymore. So an example, just in our normal everyday experience, would be something like a regular internal combustion engine. You have pistons and you have cylinders, you have a drive shaft, and you have connecting rods. You know, at least you've got those things. You also need a cylinder head. There's a set of parts that you need. If you remove the pistons from the engine, will you have the property of an engine anymore? No, you don't. So what Mike Behe points out is there are many systems that are like that in living things. And natural selection can only work on things once they're working. Before they start working, natural selection is blind to them. So for these systems, you've got to have all these parts that come together, and once they start working, maybe natural selection can work on them. And again, you can see this as actually a pretty good analogy when you start thinking about engines. When you think about the very first internal combustion engines that were made, they weren't very efficient, but over time, they have been modified into these amazingly efficient and reliable engines that we have in our vehicles today, at least if we drive a Toyota. But not so much sometimes when you drive Rolls Royces, I've discovered. But anyway, we won't go down that path. The point is this. These systems, these irreducibly complex systems, do not look like something that could evolve on the basis of the property that they have when all the parts are present. So what alternative explanations might a Darwinist come up with? Now, let me just point out something before we look at these things. When you are operating within a paradigm, you can always come up with an explanation to keep that paradigm alive. What needs to be evaluated is not whether or not you can come up with an explanation, but whether or not that explanation seems reasonable or not. So, for example, I could operate within the paradigm that everything is done by pink fairies. And you might come back with, well, I don't see any pink fairies around here. Well, then I can come back with, yes, the pink fairies only work when we're not looking. Okay? Is that a reasonable explanation or not? You know, I personally don't think it's a reasonable explanation. So I don't think that the pink fairies theory is very good. When it comes to the theory of Darwinian evolution, you can always come up with an alternative explanation. So I'll tell you what one or two of them are. Probably the best one that I'm aware of is the idea of co-option. So this idea says, sure, obviously you're not evolving this system until it gets whatever property it is that we want it to have, like the being an engine property. But think about a car engine. It's made out of steel. And you know what? Boat anchors are made out of steel too. And in fact, an engine, a car engine that lacks cylinders makes a pretty good boat anchor. So what could happen is, now I don't want to be too flippant about this. The idea is you can have maybe something, a part developing as part of a machine over here that does something, and another set of parts over here developing as a machine, another molecular machine that does something else. But it just so happens that some of the parts from each of those machines can combine together to make a third kind of machine that really does something cool. And then you can start evolving those parts so that they work better. as parts of that machine. So you're co-opting something from here and something from there and putting it together to get that new emergent property. Obviously, there are, then once you come up with your alternative explanation, I can come up with reasons why I don't think that's a very reasonable explanation, and then you can argue, the Darwinist can argue that no, this is why it is a reasonable explanation, and you can go back and forth really until you both die. But my encouragement to you is when you look at these things, really ask, is that truly a reasonable explanation? Is that something that we see happening in our normal experience? If it does happen, by the way, is it true that, I come from a family that actually does this all the time, takes some parts from one thing and some parts from something else and puts them together to make what they hope is something better. That's something that we do. But is that because of intelligence, or is it just because of random events? Well, it's because of, generally speaking, intelligent engineers may co-opt things. But all by themselves, these things still don't happen. And there are multiple other issues with that particular theory. But does that address your question?
Sure. Yeah. Thanks.
And just to kind of explain for those of us who haven't studied science, how are fossils created?
Okay, where do fossils come from? There are different kinds of fossils. So different fossils can be formed in using slightly different processes. But the typical process in the formation of a fossil would go something like this. You have a living organism, and then it dies. Generally speaking, it has to be buried after it dies relatively rapidly. Typically, this would happen underwater. And it gets buried in mud. And over time, more stuff gets piled up on top of that mud. The water moves out of the mud. It could be because the mud gets lifted up because of volcanic tectonic activity and things like that. And minerals inside the mud then glue all the pieces of, all the little tiny fragments of mud together so that it turns into rock. And at that point you have encased in the rock whatever parts of that organism have not rotted away or dissolved away already. So that would be sort of the basic way in which things happen. This is why, by the way, typically you find fossils in rocks that are formed underwater, and typically you find hard parts like shells, bones, teeth, and typically you don't find soft parts of the organisms.
Thank you. Then just maybe a follow-up, unless you were going to talk about something.
Sure, go ahead.
What time frame do you put on this fossil record? You're saying you're using these millions or thousands of years. So if that is not the ideology that you've taken, how do you take the fossil record and then put it into your Christian sense?
I will tell you that my personal belief is that when you're trying to figure out what happened in the past, it's generally best to, if you have one available, go with a written record. Somebody who was there is probably more likely to know what happened than me. And as a consequence of that, I go with the biblical record of history. Now, how does that fit in with the fossil record?
With layers, and how do you put millions and billions of years to now only a few thousand?
Here is what I would say about that. I personally do not put millions and billions of years in there. My belief is that the fossil record has formed over thousands rather than millions of years. There are some people who want to say, hey, the entire fossil record or the vast majority of it formed during the flood there in the book of Genesis. I would not be surprised if a substantial portion of the fossil record formed during that cataclysm. However, I don't think that it's necessary to ram everything in there. I'm not uncomfortable with the idea of some fossils forming prior to the flood and obviously some fossils forming subsequent to that event. But I'd probably imagine that the majority would be in there. I should tell you, I am not a geologist. I'm a biologist. So I have a tendency to look at these things from the perspective of a biologist. And frankly, looking at the fossils from the perspective of a biologist, I just think that the geologists have got it wrong. That's, and I'll tell you why. There are multiple reasons, ways of estimating how old rocks are and how old fossils are, and so on. But because I'm a biologist, I have a tendency to be interested in how long biological things last. And the soft parts of organisms simply do not last that long after an organism dies, typically. If you dry them out and mummify them, they may last a significant period of time. And there may be some other ways of preserving things a bit, like putting them into bogs and stuff like that. But generally speaking, we don't expect molecules like proteins, RNA, DNA, polysaccharides. It's not that they don't last for a significant period of time or can't last for but millions of years simply doesn't seem to be how long these things last, particularly if you bury them in the ground. And there are multiple reasons for that. Obviously, bacteria can get to them and break them down. There's also certain thermodynamic processes. There's things like background radiation that breaks apart these large, complex biological molecules. So the idea that they would last millions of years or tens of millions of years is frankly pretty preposterous, both in theory, and by the way, these things have been studied a lot because it's very useful to know how rapidly they break down for forensic purposes. And so in the laboratory, we can see that they break down at a specific rate. In experience, we know that they break down relatively rapidly. And yet we find these things in the fossils. Soft tissue has been found inside dinosaur bones. And not just one or two dinosaur bones. Sue, the T-Rex at the Field Museum in Chicago, it's a fantastic specimen. I believe it was one of her bones, or his, depending on, I think this fossil is thought to have been of a female. But I think it was one of her bones that soft tissue was found in. Have you ever done that experiment where you take a chicken bone and put it into vinegar?
No.
Oh, that will remove the mineralized component, and you'll wind up with just the rubbery protein component of the chicken bone. It's kind of a cool, fun experiment to do. Yeah, go home and do that tonight.
I shall.
Yes. But basically, something similar to that has been done with dinosaur bones. And, dinosaurs are supposed to have gone extinct 65 million years ago. There is no way that soft tissues like that will last that period of time. I mean, it's just an extraordinary claim that it does. So, and by the way, some of my colleagues and I have started to collect papers on this. in the peer-reviewed scientific literature. We have over 400 papers reporting different kinds of biological molecules isolated from fossils. Probably the most astonishing to me has been the discovery of unsaturated fats. You know,
Wow.
yes. Have you taken organic chemistry?
Yes.
Yes. I mean, unsaturated
That's
fats. I find it hard to imagine how these things could have lasted thousands of years, frankly. Yeah, so that's one scientific reason why I personally have my doubts. But I want to tell you that my belief about this is based on my faith in the accuracy of the Bible. I don't think that we can pin down the exact day and hour that God started the creation, but certainly things look like we're talking about thousands, not millions of years there, at least when it comes to living things.
I have some more questions on that topic, but go ahead.
Thanks. You said regardless of time, you still believe there is intelligence behind all of these
Yes.
fossils. And if I understood correctly, when you were showing these different phases of a fossil record, it appears that they appear gradually in their complexity and everything. So, is it a fair question to say maybe there's intelligence, but when we read the Bible, in Bible we read in Genesis that life with its all complexity appeared almost at once. And here we see this gradual progression. So while we may say as Christians, yeah, there is intelligence behind it, but they may claim, yeah, there is intelligence maybe, but it's not all at once.
Yes.
So how do we explain, the record of the Bible, all complexity is there, at once, and when we look at the fossil record, it doesn't seem that way.
Yeah. Let me address that, but I think there's a little bit of a misnomer that I need to address first. When you look at the fossil record, the stuff at the bottom doesn't look less complex than the stuff at the top. Probably the best place to look for a trend is in the vertebrates. In these are organisms that have a backbone, as we do. And that's probably as good as it gets. In the Cambrian rocks, you find fish. They do tend to look less like organisms living today. And up near the top, you find organisms that look more like organisms living today. To me, that's probably the best evidence that you can get for Darwinian evolution in the fossil record when you look at vertebrates. It's nothing like as clear when you look at invertebrates. But I think you can make a reasonable case for, with vertebrates, you do have a trend of some sort there. And people have come up with any number of interesting theories about why that is. Some people believe that what you're seeing is a reflection of the ecology of the time. So if you look at our current situation, way down deep in the ocean, you have some really weird-looking fish and things. If you had a global flood where you're washing all this sediment off of the continents and they're going down, what's the first thing they're going to cover up? Well, the weird-looking stuff at the bottom of the ocean. And then, above that, you'll start getting things that lived on land, various levels in the ocean, and then what lived on land. That theory is one that has various problems to it. Another theory has to do with corpse flotation time. If you take fish reptiles and mammals, and you kill them and put them into water, fish sink first, then reptiles, then mammals. And so there you get that sort of progression again. That's an interesting theory. And there are some others out there. However, my bottom line is this. I've listened to lots of theories about long periods of time in the fossil record and how it explains things. It really doesn't do a very good job of explaining what you see there, particularly if you look at, all of the generally accepted trends that you see there, things like sudden appearance, things like, with birds, you see, and apparently with some organisms, but birds I'm more familiar with, you have this, what you should see is dinosaurs, and then feathered dinosaurs, and then primitive birds, and then modern birds. That's sort of how you should see things as you come up through the fossil record. But in actual fact, you see a pattern that's almost exactly the opposite. What you see is you do see dinosaurs show up first, and then basically at the top of the Jurassic and the lower part of the Cretaceous rocks, you see birds, lots of birds, really weird birds. I mean, some birds with long tails, some birds with teeth in their mouths, some birds with long tails and teeth in their mouths, some birds with short tails and teeth in their mouths, birds with little fingers on their wings, really kind of lots of really weirdly different kinds of birds. And by the way, they appear all over the world. You have them in England, you have them in Spain, China, Mongolia, they've been found in Australia. So I mean, just all over the place, they show up right in the upper Jurassic, lower Cretaceous rocks. And you also find modern birds. So then you find the feathered dinosaurs that are supposed to be the ancestors of birds. And then you find the dromaeosaurids basically above them, and the dromaeosaurid dinosaurs are the ones that are supposed to be the ancestors of birds. So what you have is an arrangement that is essentially the opposite of what the Darwinian mechanism is supposed to have produced. So you have things like that. And when it's all said and done, and I guess, I hope that you'll excuse me for doing this as a biologist, but you know what? I will tell you, I have yet to hear a theory that actually explains all of the trends that you see in the fossil record. I've listened to the creationist ones. I've listened to the ones that Darwinists believe. None of them works very well. And, it's okay to at least it seems to me to be okay to understand that we really don't have a good explanation. Better to know you don't know something than to get caught up in an idea that, frankly, is obviously wrong.
Yeah. Maybe just a question that we had from audience that can tie into
Sure.
this. Are there any fossil records of animals, organisms, we cannot find in the modern world? I think you just mentioned some of them.
The
If
trilobites. Trilobites no longer live. They're, and yet we have a great fossil record of them.
And the question is, if this is the case, does this prove evolution?
I'm trying to understand why.
If we can find in fossil records some organisms, some animals that we don't have today, does that prove evolution?
No. Organisms go extinct, and unfortunately it seems like a lot of organisms are going extinct right now. I mean, I don't see how that proves evolution. I don't see why it logically
Maybe
would.
that answers another question that we had here. How do you explain dinosaurs from creationist point of view?
Okay, here again, I want to be very careful. Remember, I'm a biologist. I don't claim to be a paleontologist or a geologist, and I don't claim to be an expert on dinosaurs. So, take my answer with that degree of authority. Okay. Here are a couple of things, however, that I do know about dinosaurs. First of all, while we tend to obsess about the truly gigantic dinosaurs out there, most dinosaurs were not unusually large creatures. Most of them were, sort of in the range of, I don't know, a big chicken to, cow sort of range, size range sort of thing. So if they were living today, most of them would not be, we wouldn't consider them to be horrible, gigantic, dreadful creatures. Furthermore, many of them were vegetarian, grazing kind of organisms by the look of it. It's the rare exception that you see on television. And that rare exception is the gigantic carnivore like T-Rex or something like that. Or these titanosaur dinosaurs that are just gigantic. That's why we find them interesting, because they're so unusual. That's why they're newsworthy. But normal dinosaurs look to me like normal kinds of creatures, and I don't personally feel compelled to explain them as anything other than organisms that were probably created by God, along with the other kinds of organisms that have unfortunately gone extinct. And just to put things in perspective, by the way, trilobites, they disappear at the top of the Paleozoic rocks. They are believed to be completely extinct. They represent a whole, probably subphylum of organisms. Some people actually put them into a phylum, but anyway, a whole at least subphylum. So I mean, that's a really big taxonomic group. All of them gone. Whereas dinosaurs, they're just one kind of reptile that seems to have gone, or actually potentially two kinds, because we might be lumping two quite different kinds of organisms together there. Anyway, I hope that addresses the question.
I have a couple of questions related to the flood, all kind of, whether directly or indirectly. Firstly, if we see, or in most science classes we're taught that there is a bunch of different sedimentary rock that laid over time, and in those different sediments we have different fossils that correspond to different eras, which you showed us. If there was something like the flood, a cataclysmic event that was worldwide, wouldn't all that water have churned and developed and resulted in more of a uniform layer and not so much these sediments of different timed fossils?
Sorted out.
Yeah, why that organization?
Yeah, I'll give you a very simple answer, and it actually relates to what I was talking about before, the formation of the fossil record. And I'll do that by using the three most useful words in the English language. I don't know. I really don't know. I can't travel back in time. I can go and I can look at, some events that seem cataclysmic to us, but on the scale of whatever the event that's described in the Bible, they really don't. They really just don't compare. My only observation has been that consistently kinds of rock that are supposed to be laid down over very short, very long periods of time contain evidence of being laid down over very short periods of time. I'll give you an example. It's not a pretty thought, but it kind of illustrates it quite nicely. When you have very, very finely ground up sediment in in the water, like clay particles, they take a long time to settle out of the water. And so you would expect that rocks formed out of those particles would be would take a very long time to form. And yet, what we find are these very finely laminated, very, very small layers of rock, zillions of them, one above the other. Sometimes people actually think that each one of these layers represents 1 year of sediment on the bottom of a lake. Yeah, they're there, and yet what we find inside them are fossilized coprolites, which is basically fossilized dung. You know, I don't know about you, and I personally have not done this experiment, but placing feces in water and waiting for years doesn't seem like a very good mechanism for getting it covered up by little, very small layers of rock that build up, 10, 20, 30, 40, 50 layers until the whole thing's covered up. So presumably there is some alternative explanation for that sort of thing.
And then whether you want to relate this to the flood or not, you decide. But if we believe that humans existed at the same time as many of these species, if not all of them, and we have events such as, Mount Vesuvius. The volcano blows up, humans are covered in volcanic ash and essentially fossilized, and they're still preserved today. Do we see any kind of record of human remains low enough in the fossil record to kind of upset this evolution theory, or
there are people who believe that they have found evidence like that. I personally have not found any of that evidence to be particularly compelling.
And is that a problem?
Well, obviously it would be kind of nice to find, a T-Rex with a human skeleton in its stomach or something. Just because that would illustrate that these things existed together at the same time. For whatever reason, there is order in the fossil record. That appears to be a real phenomenon. The trick is to come up with a mechanism that actually explains that order. And as I said, I've looked at, from a scientific perspective, I've listened to and I've read, a lot of what geologists have to say on all sides of these things. And I'm being completely blunt with you. I have not seen a creationist theory that works. I have not seen a materialistic theory that works for what we see. Now, I can come up with possible reasons why that might be. For example, you could say, God was very orderly in the way he created things, and the flood story is kind of a decreation. So maybe God was really orderly in the way he decreated the earth. But that's just a speculation. It might be true. However, I don't want to send you away with the idea that somehow or other I've got some magic bullet theory that just accounts for everything. I don't. But neither does anybody else. And please, for your own sake, be very skeptical when somebody comes along with their brilliant theory that solves everything. Listen to them. They might have figured it out, but they probably haven't. And I mean that on all sides of this. I'm not sure that we necessarily should even expect to get a great answer if we believe that the flood involved some kind of divine intervention, which I happen to. maybe there simply is not a great naturalistic theory in principle with this because it's not a purely naturalistic event. Yeah.
Okay.
Thank you. I think our time is up tonight. We have more questions here that were asked. Hopefully tomorrow we'll have more time and people will have more time to interact with you one-on-one.
I'll look forward to that.
And get answers to some of these questions. Before we leave tonight, I want to invite you tomorrow, 10 o'clock. We are going to have presentation History of Design Argument. And at 11, we are going to have one which I'm really excited to hear, Why God is God. So we are inviting you to be with us tomorrow, and we wish you a good evening and restful night, and hoping to see you here tomorrow. Thank you very much. Thank you.
Thank you. Oh, thank you.
I recently saw a very funny picture. Somebody put there the monkey, there the human, and you know the whole progression from monkey to human.
All right.
They said, look, we have billions of these, we have